Mr. Ainsberg here to go over the Chapter 6 practice test multiple choice questions. Now remember, these videos do not go over just what are the right answers, but also how to deal with analyzing, crossing out choices, and really even how some of the wrong answers for a question might be the right answer on other questions. So the first prop we're given deals with questions 1 and 2. We're told a psychologist study the number of puzzles that you can have subjects complete in a 5-minute period while listening to soothing music. Let X be the number of puzzles completed successfully by a subject. That's our random variable, and we're given the probability distribution of X in the table. We're being asked what is the probability that a randomly chosen subject completes at least 3 puzzles in the 5-minute period while listening to the soothing music. So first thing I'm going to figure out is what am I being asked to find? And I'm being asked to find the probability that my random variable X is greater than or equal to 3, at least 3 puzzles. So X has to be greater than or equal to 3. So if I'm looking at the table right away, that's telling me that I'm probably looking at 3 and above. So my brain's going to, okay, I'm thinking 0.4 is the answer. So let me kind of also talk about why some of the other ones are not the answers. And so if you look at A says 0.3. That's the probability of X being just equal to 3. So that's somebody not understanding the direction of the probability. Even choice C of 0.6, that's a probability of being less than 3. Not including 3, just less than 3. Again, misunderstanding the direction of the probability. And then you have choice D, which is 0.9. In that case, it is less than or equal to 3. And so you can see how they came up with 3 of those choices. It's based off of misunderstanding the direction of the probability. So I'm still going through the idea that it's 0.4. And so what about choice E? Cannot be determined. Now that one you have to kind of think for a moment. That's actually a really good answer. And the reason why is what that's really asking us is, are we dealing with independence? Is the ability of one person to complete a puzzle under the conditions being set, is it going to impact another person completing that puzzle? So in this case, no. That one person is not going to impact another, so it is independent. So therefore, I can keep on doing the probability. But I would choose choice E if it was not independent. So don't just throw that one away. That's where choice E came from, is the idea of independence and not independence. So again, I'm sticking with the idea that the answer is 0.4, and it is 0.4. Now, I'm going to go ahead and give you a warning. I thought that was a little too easy. I'm going to tell you what I would have done. I would have made one of the choices 0.1, because in that case, it would be the probability of X being greater than 3. So if we look at this, it does say that you have at least 3 puzzles, so that does include 3. Now, I would find a way to make it so it would just say more than 3 puzzles. Then it doesn't include 3, and I would have made one of the choices 0.1. So I would have done that. That would have been a trickier one. So just a little heads up, that is one type of problem that they could ask. All right, so let's move on to question 2, which deals with the same prompt. Now in question 2, we're being told to suppose that we have 3 randomly selected people, and they complete the puzzles for 5 minutes each. We're asked to find the expected value of the total number of puzzles completed by these 3 subjects. All right, so I'm going through. I have the same table, same information. Now, first thing I'm going to notice is I do see it does say find the expected value. So that's the mean of my random variable X. Okay, so that's easy. I'm just going to go ahead and calculate that. So remember, what you do is you take your value, you multiply by its associated probability. You do that for all of them, and then add them together. I get 2.3, which is choice B. So I'm being asked to find the expected value, so I'm going to go ahead and say the answer is not 2.3, because I stopped reading. Just because the problem says find the expected value doesn't mean that's what you're going to do. Because if I kept reading that sentence, it would say find the expected value for the total number of puzzles completed by the 3 subjects. So really what I'm dealing with is I'm going to go ahead and say let T equal the total number of puzzles completed by the 3 people. And in that case, since each one says 5 minutes each, I'm going to take 3 times that mu of X. I can expect one of them to do, 2.3 puzzles. So if I'm going to go ahead and say, I'm going to figure out that 3 of them are going to be 3 times that. So B is actually a wrong answer. It does not take into account the 3 subjects. It's a trick. you stop reading the problem, you're going to say the answer is 2.3. Now, C is also another problem. C, what that does is it takes the mean of your x. The 1, the 2, the 3, the 4, it takes the mean of the value of x. It does not take the probabilities into account, nor the 3 people, which is very weird. If you look at it, one way they might have come up with this is that instead of doing 1-bar stats, L1, L2, which remember you put your values in L1 and their associated probability in L2, the calculator calls it frequency. Instead of doing L1, L2, maybe they just did L1 for that one, and that's where they got the answer. They didn't take into account the associated probabilities. Now, E is the answer from choice C multiplied by 3. So, maybe someone did that, and hey, I know I got to multiply by 3, so therefore I'm going to multiply 3 by say the answer is 7.5, which is wrong. The answer is 6.9. What you need to do is you need to take 3 times our 2.3. So we knew that this one was wrong because it did not take into account the 3 subjects. So if I take 3 times 2.3, I would get the 6.9, which is the answer. And that's question 2. Moving on. So now in question 3, we're told, suppose a student is randomly selected from your school. I like how they're doing random selection. That might be important. Which of the following pairs of random variables are most likely independent? Okay, so independence, that's the key word here. Is one variable impacted by another variable? The question is, if the answer to that is yes, then it's not independent. If the answer to that is no, then hey, good news, it's independent, it's the one we're looking for. So in this case, I have to read all the choices. So I just have to go down the list. Now there's a really good answer, I'd say a good wrong answer here, because it kind of makes sense with the directions. So if I go through student's height and student's weight, are those independent? So is a student's weight impacted or affected by their height, or vice versa? And the answer to that is yes. Taller students do tend to weigh more. And so that is a chance of being dependent, not independent. How about students' IQ and students' GPA? Those could impact each other. Students' IQ can influence their GPA, so that's not it. Okay, what about students' PSAT math score and their PSAT verbal score? Now you may be going, okay, well math, verbal, those aren't related, so those are independent, and maybe that's my answer. And I'm going to tell you, put C on hold. Put it on the back burner for right now. And the reason why is I'm going to kind of show you what the directions for multiple choice say. Select the best answer for each question. Now, I'm going to put C on hold, but I want to tell you the ability to do well on one, the math or the verbal, can impact your ability to do well on the other. So C is not independent. However, let's pretend we don't know that. Just because let's go ahead and say, ooh, that's a tough one, just move on. Hey, you eliminated A and B, let's just keep C there and see what happens. And so I go to D, the average amount of homework a student does per night in their GPA. Contrary to popular belief, students, that is dependent. Not doing homework, FYI, can affect your GPA. So right now, I'm on choice E, the average amount of homework the student does per night in a student's height. So do taller students tend to do less homework or more homework than shorter students? So that seems weird. So I'm stuck on C and D. Well, I'm going to go back to the original directions. Select the best answer. Now, again, the ability to do well on math or verbal for the PSAT can impact the other. They are not independent. But if I did not know that, then I have to choose between choices C and E. And between those two, the one that really does seem like it is the most likely independent ones is going to be E, the average amount of homework time spent and a student's height. So this was a really good question because it kind of brings back that direction. Select the best answer from multiple choice. So if you ever get stuck between two, you don't know which one it is in this case, which one actually is the best one. All right, so that's question 3. In question 4, we are told a certain vending machine sells 20-ounce bottles of soda for $1.50. The number of bottles X bought by the machine is a random variable with a mean of 50 and a standard deviation of 15. So that's telling me I have a random variable X, mu of X equals 50, and sigma of x equals 15, let the random variable y, so now there's a second random variable, equal the total revenue from this machine. Revenue means, okay, I see they sell for $1.50 each, so I think that $1.50 is associated with the y variable. And then assume the machines work properly and that no one's stealing from them. What is the mean and standard deviation of y? So we're being asked for mu of y and sigma of y, not mu of x and sigma of x. Keep that in mind. So we are first given information on mu of x and sigma of x. So you can see I have that highlighted in blue. Mu of x equals 50, sigma of x equals 15. But the problem tells us we want to look at the random variable y, the revenue generated by that random variable x if they're sold for $1.50 each. So in that case, I'm given that information. Y is the revenue generated by the machine on any given day. So that means y equals 1.5x. So I'm dealing with transformations here, because I'm taking $1.50 for every single one of those being sold. So I'm multiplying by 1.5. So that means that how does transformations work? Multiplication with our means and standard deviations. So I'm going to take 1.5 times mu of x. That's going to give me my mu of y. And I'm going to take 1.5 times sigma of x, and that's going to give me my sigma of y. So right away I know I'm multiplying my mean of 50 by 1.5, which means I can eliminate choices A and B right away. Those do not take in consideration the right mu of x. It's saying, hey, $1.50, but you have to realize it's 1.5 times mu of x, so 1.5 times 50. So now I have to figure out what is the difference in my choices. So of the remaining choices, the difference is my sigma of x. You can see there the answer is 22.50. Because what I'm going to do is I'm going to take my 1.5 and I'm going to multiply 1.5 times my sigma of x, which is 15. So that would be 15 plus 7.5, which is 22.5. That's where I get the answer. So D is it. I could eliminate two choices right away. It gives me a 33.3% chance of guessing. But I also want to talk about how they came up with the other answers, because they all have mu of y equals 75. So really, what did they do wrong with the standard deviations? And in this case, here's what we need to figure out. We need to realize what they did is they looked at a conceptual misunderstanding of transforming versus combining. So you can see how they came up with C and D off to the side, but I really want you to realize that we looked at two different things, a transformation and a combination. Are you combining two random variables, or are you doing a transformation on one? And in this case, you can see I have transformation in green, because that's what's going on. Each random variable x is being multiplied by 1.5 because that is the revenue associated with the sodas. So I'm going through and I'm doing with a transformation on x. That's why you see the equation y equals 1.5x. The other ones, the C and D options off to the side, deal with different errors in combining. Those aren't the right ways to combine either, by the way. They are just mistakes on it. So not as much here. You'll see this also plays a role in a future question on transforming versus combining. So it's a very important idea to realize, why do we define our variables, so we can understand, is it a transformation or is it a combination if we have more than one? And in this case, it is a transformation. Let's move on. So questions 5 and 6 both deal with this prompt. We're being told the weight of tomatoes chosen at random from a bin at the farmer's market is a random variable. So we have a random variable. The mean of that random variable is 10 ounces, and the standard deviation of that random variable is 1 ounce. Suppose we pick 4 tomatoes, and we want to find what the total weight T is. So 4 tomatoes being picked at random, what's the total weight T? So let me keep this in mind. I want to find what is the total weight, the expected total weight of those. So I'm going to say T equals the total weight. So I define now what that's going on. But first, let me do something. If 1 tomato is expected, because the mean for a random variable is what you expect. If one of those is 10 ounces, what do you think the mean or the really expected weight would be of 4 of them? I bet you it's going to be more than 10. So I'm just going to cross out A, B, and C. Because if 1 tomato has an expected weight of 10 ounces, I'm going to go ahead and say 4 tomatoes, probably going to be bigger than 10 ounces. So I can eliminate A, B, and C. Now, really, I want to talk about what's going on. B is really looking at this 4 times standard deviation, 4 times 1. If I look at this also, here's what's really interesting. A is 10 divided by 4. So therefore, we have the 10 ounces divided by 4. You're taking the expected weight of 1 and cutting it into fourths. That's not grabbing 4 of them. So I'm going to cross out A, B, and C, and hopefully you understand the logic behind that. But I want to also talk about what's really going on. What's really going on here is you are reaching into that bin and you're taking out 1 tomato, putting it to the side, taking out another tomato, putting it to the side, taking a 3rd tomato, and then a 4th tomato. So really, what I'm dealing with here is a combination, because I'm taking 1, putting that aside. Because we have the mean weight of one of those, the expected weight of one of those is M equals 10 ounces. Then I grab another one. The expected weight of that second one is 10 ounces. The expected weight of the third one is 10 ounces. The expected weight of the fourth one is 10 ounces. So I'm really combining them together. And so therefore, what I'm really dealing with, is I'm dealing with 10 plus 10 plus 10 plus 10. So keep that in mind. This is actually a combination, because you grab one, hey, this should have an expected weight of 10 ounces. Put it aside. You grab another one, this should have an expected weight of 10 ounces, and so on and so on. And so I'm going to say the answer is 40. So keep that in mind. Again, notice how I said it's a combination. That's going to play a role in the next question. Here we are in question 6. Remember, I used the same prompt with tomatoes. So do keep in mind, I did point out an important fact, that we are combining. And so keep that when we're reading this question 6 in mind. This problem deals with combining random variables, because if you were grabbing 1 tomato out of the box, hey, we expect a mean of 10 ounces and a standard deviation of 1 ounce for this. That's nice. Put it away, grab another one, and so on. The random variable t, because remember t is the total weight, the random variable t has a standard deviation in ounces of what? Oh, well, if one of them has a standard deviation of 1, then it probably is going to go ahead and say the standard deviation is 4. And so the answer is not E. That is a conceptual misunderstanding. And the reason why is you do not add standard deviations when you are combining random variables. Notice right away that's going to be one of the multiple choice ones, because that's a conceptual misunderstanding. Is you do not add standard deviations when you are combining random variables. You're going to have to figure out, well, how do we combine with the standard deviations then? And you don't do it by adding them. So right away, choice E is a very quick trick for people to go ahead and just grab, bam, wrong. Why? Because, well, that's what we did for question 5. We added the 10 plus 10 plus 10 plus 10. Hey, 40. That's not how it works with standard deviations. So how do we combine? And what we do is we combine variances. You do not combine standard deviations, you combine variances. So how do we combine variances? Because we have to figure out, well, I'm dealing with a combining random variables. So what do I do? And really you have 2 choices to kind of think about. We're either going to choose choice 1 or choice 2. Choice 1 says what you can do is you can add the variances together for each random tomato that is selected. Choice 2 says, you know what, let's take 4 times our standard deviation and then square that, which means I'm going to really square the 4 and I'm going to square the standard deviation. Now, one of those is right and one of those is wrong. And so that's why I like this problem right here. It really does relate to one of the previous questions where we dealt with transformation and combining random variables. Which one of these is right? And what's interesting about it is one of these choices is used if you are combining random variables, and one of these choices is used if you are performing transformations on random variables. So you can see why it's important you understand when you read the prompt which one you're dealing with. And so if I look at this, that is the main idea. A conceptual misunderstanding, and the other choices deals with transformations versus combining. And this time you can see up above I have combining in green because that's what we're dealing with. We're not dealing with transformations. So just so that you are aware, the number 2 choice is actually dealing with you are combining them together, which means choice E is a double trick. Let's say you're the student who goes, I know I don't add standard deviations together, and you know, okay, well, I'm not going to go ahead and do 1 plus 1 plus 1 plus 1. I'm going to take and I'm going to square everything. So I'm going to multiply these together, and then I'm going to square it. That'll be 4 squared and my standard deviation squared. And so I'd have 16 times 1 squared. And so that'd be, okay, 16 times 1, 16. But that's my variance. So my variance equals 16, which means my standard deviation would be the square root of 16, which means my standard deviation would be 4, which still is wrong. Because choice 2 is how you deal with transforming random variables. Choice 1 is what you deal with when you are combining random variables. My variance is going to be, in this case, 1 for the first tomato squared, because that's the variance of selecting that first random tomato. Let's put it aside. I'm going to reach in the bin, I'm going to grab another one. You know what? What's interesting is this has a standard deviation, expected standard deviation of 1 ounce. So that means its variance is going to be 1 squared. And I do that again for the third and the fourth. That's going to be 1 squared plus 1 squared plus 1 squared plus 1 squared. That's going to be 1 plus 1 plus 1 plus 1, which means 4. Still not E. Because what we did is we found the variance of t. So I'm going to have to square root both of those and say the answer is D. The answer is 2. I really like this problem and the other problem because it has you figure out what's the difference between transforming and combining. So keep in mind what's interesting is how did I do the work in question 5? In question 5, what I did was I took 10 plus 10 plus 10 plus 10. I took mu of x plus mu of x plus mu of x plus mu of x because I was combining. So how am I going to deal with these standard deviations? Well, I'm going to combine the variances the same way. The variance of x, the variance of x, the variance of x, the variance of x for each of the tomatoes. So I really liked question 6. Let's move on. So question 7 is asking us which of the following random variables is geometric. So geometric, remember, you always check the bits for geometric. Is it binary? Is it independent? Do you have a number of trials until a success occurs? Are you looking for the trial that the success occurs at? And is the probability of success consistent? Is it the same throughout each trial? So I'm going to have to check those for each one. Now, don't get this confused with binomial, by the way. Binomials check the bins. Geometric is check the bits. Don't worry, we're going to get to the binomial soon. So question 7, choice A, have to read them all. The number of times I have to roll a die to get 2 6s. Okay. I have to roll a die, so that means I'm rolling 1 die to get 2 6s. Oh, so right away I'm looking at the number of times until something happens. That's good news. That tells me I'm leaning towards, I got the T checked on that one. So maybe it's geometric, but something is different about this one. I roll a die to get 2 6s. So think about that. If I'm rolling a die and I get a 6, I can proceed to roll the die again to try and get that second 6. If I roll a die and don't get a 6, I have to keep going until I do. And well, hey, you know what? Hey, I got a 6. I still have to roll a second one. So that second roll is dependent on the fact that I have to roll a 6 on the first roll. So just because you roll 1 6 doesn't mean, hey, I'm good. After you roll 1 6, you better roll another 6. So therefore, I'm really not thinking that it's independent. I think that, hey, you are looking for T, number of trials until a success occurs, but it's not independent because you're rolling 1 die, and that second 6 is dependent on did you roll a 6 on the first one. So choice B says the number of cards I deal from a well-shuffled deck of 52 cards until I get a heart. Okay, so I see the T here, the number of cards until something happens. But if I'm dealing cards from a deck, I'm not replacing, which means I'm decreasing the number of cards in the deck. I'm going from 52 to 51 every time I go through to 50 to 49 and so on. So I'm going to go ahead and say A and B are not independent. And so that's a really good thing. I can cross those out. I know it's not A. I know it's not B. So now I'm on C, D, and E. So let's just go ahead and go. C, the number of digits I read in a randomly selected row of random digits until I find a 7. Okay. Until I find a 7. 7 is success, not a 7 is failure. So I know I have the binary. Is it independent? Well, yeah, it's a random digit table. So The digits are randomly there. One's not impacted by the other. Am I looking for number of trials until success? The number of digits I read until something happens? Yes. Probability of success till I get a 7? No, it's 1 out of 10. C looks good. That doesn't mean I'm going to highlight it yet. I'm leaning towards C. Let's read D and E. The number of 7s in a row of 40 random digits. Hold on. So a number of 7s in a row of 40 random digits. Do you see how that's worded differently? Or even the number of 6s I get for choice E if I roll a die 10 times. Those are actually have a restricted number. You can only deal with 40 random digits or only deal with 10 rolls of the die. So I'm restricted. I'm not looking for the number of trials until a success. I'm looking for the number of successes in a set number of trials. Well, that means D and E, those are binomial. D and E are binomial, while C is geometric. Both D and E are binomial on, hey, do you get a 7 when you look at the random digits, or don't you? Okay. Do you roll a 6 or don't you? They're independent, yes. They both have this consistent probability of success, but you're looking for the number of successes in a set number of rolls or a set number of random digits. That is binomial, not geometric. Do expect that when you're dealing with a multiple choice question on which the following scenarios is either geometric or binomial, they're going to throw the other one in there to try and trick you. Let's move on. All right, question 8. 17 people have been exposed to a particular disease. Each one independently has a 40% chance of contracting the disease. Notice the word independent there. That's very crucial. A hospital has capacity to handle 10 cases, so a hospital can have 10 people with this disease, and they can't deal with any more. What is probably the hospital's capacity will be exceeded, which means you're going to be going beyond 10. So I'm really looking for the probability of X being greater than 10. So if I'm looking at this, 17 people have been exposed to a particular disease. So if I'm going through, what's the probability that I'm going to have more than 10 cases at this hospital? There's a 40% chance of contracting the disease. So in this case, what I'm dealing with is I'm going to go ahead and think about this scenario. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to stop at 17. So really what I'm dealing with is if I'm at the hospital, if it exceeds 10 cases, then they are over capacity. So that means 11, 12, 13, 14, 15, 16, etc. That means that hospital has exceeded capacity. If it's between 0 and 10, that hospital is fine. It's at capacity or less. So really, it's nice when you're dealing with these situations to kind of draw out the numbers and kind of put the line where you're separating, because this does tell me something. I could exceed it. Right now, 17 people have it. Yeah, I could have 100 people. It spreads. So I'm just going to go ahead and say right now, I'm going to have to deal with a binomial situation. There are 17 people. There are 0.4% chance that they're going to be affected. You are looking at 10 as the people that could be in the hospital at one time, at most 10. So I have a binomial setting. They're either going to get the disease or not. It's independent, and you have a fixed probability of 40% chance, and you do have a capacity there. There's 17 people who are exposed. So I do have of that 17, how many can expect to get the disease? So I'm thinking it's binomial. I'm still going to keep this in mind, though, because this is a very interesting way to look at it. Because I can go ahead and use binomial CDF. If I want to find out that the hospital is going to exceed capacity, I might as well find out what it is to the left at capacity. So if I do binomial CDF, 17 people exposed to the disease, 0.4 is going to go ahead and say that's the probability that they will get the disease, and then 10. Because remember, CDF does at that value 10 and less. So at the value 10 people, 9, 8, 7, all the way down to 0. I'm going to find all those first. Now if I do that, guess what the answer is? 0.9652, which means the answer is not D. Notice D is 0.9652. That's a trick, because binomial CDF finds at that value and less. You're actually looking for exceeding the cases. I'm looking for anything above 10. So keep that in mind, is they do have tricks that deal with the wrong direction. So I have to keep direction in mind. Again, that's why we think it's important you kind of draw this out and point the direction you're trying to find. So I'm going to keep in mind, though, that this is actually a probability distribution, which means the probability should add up to 1. So I'm going to take 1 minus that 0.9652. That should give me my answer. If I find what's to the left, by doing the complement of it, I should be able to find out what's to the right. And if I do that, I'm going to go ahead and get the answer of 0.035. Choice B is the right answer, but choice D is the wrong direction. That's the trick. See how those two are related to each other. It's really important. Now, what about the other choices? Well, choice A is the probability of x being greater than 11. So in that case, what it does is it does the binomial CDF, and it's going to put 11 down here rather than 10. C is probability of x being greater than or equal to 10, which means down here you would have 9 instead of 10. It's going to say, oh, I want 10, 11, 12, 13. That's what exceeds capacity. Now remember, the prompt says that the hospital can handle 10 of them. So 10 is at capacity. Anything beyond that's not. And then you will have the x less than or equal to 11 for the other one. So you do see how they can come up with some of the other ones, but the main idea, I think, is that B and D is that they are complements of each other because of the direction. And that was the hard part of this one. And that's why whenever you're dealing with one like this, just write out the scenario, list them out, draw the line, point the direction you want to go to help you figure out how to solve it. Let's move on. All right, question 9. You can see we're given a graph. This figure shows a probability distribution. We don't know which type. It's a discrete random variable. Which of the following best describes this random variable? Is it binomial or geometric? That's the difference between choices A through C, D, and E. And then, if so, what's the probability? And what's the number of trials? Well, good news is this. If it's binomial, they all have n equals 8. The only difference is between A, B, and C is the probability. Geometric is the probability. Well, how do I know if it's geometric? And that's one thing to keep in mind. This was something we talked about, and it's briefly touched on. We focus a lot on calculating for geometric, but figure out the shape. The shape of geometric is always going to be right skewed. It is always going to look like something along those lines. And the reason why is because you're looking at success when the first success occurs. So it's going to be rare for it to take 50, 60, 70, 80 times until that happens. So it's going to be right skewed for geometric, which means I can eliminate those two choices. I can see up above that it is slightly right skewed, but I mean that right there is extremely right skewed. So I know it's not going to be geometric. So if I look at this one, I can go ahead and I'm going to label. I'm going to label the intervals, and you can see I have 0, 1, 2, 3, 4, 5, 6, 7, 8 right there. I can label in between each one of those for the histogram, and I'm going to go ahead and look at what am I dealing with. Well, it does appear slightly right skewed, but you do have some information over there on the left side. But it is tailed off to the right there. So what does that mean? Well, that means if it's slightly right skewed, that our mean should be somewhere in those two bars, those two bins. The mean would be here for a graph that appears slightly right skewed. So the mean should be between 2 and 3, it looks like, and 3 and 4. So that's where I'm going to be looking at. So I get, because it's right skewed, man, I got to bring some stuff back from shape, don't I? If it's slightly right skewed, that means it's going to be pulled slightly towards the direction of the tail. So it's going to be between 2 and 3 and 3 and 4. So what does that mean? How does that help us? That means I have to actually calculate every single one of my means. I have to calculate each one, which means I'm going to take n times p. So a times 0.1 is 0.8. A times 0.3 is 2.4. A times 0.8 is going to be our 6.4. So which one of those is between the 2 and 3 or the 3 and 4? And the answer there is B. B is the one that is between them. So that is going to be my answer. So we had to keep in mind the shape of a geometric, which starts off at a high peak and then works its way down. So it is extremely right skewed. I mean, it starts at the highest and then works down. This one right above is slightly right skewed, so I have to keep in mind the shape of a geometric. I also have to keep in mind how to find the mean on your formula sheet of a binomial. And then I have to keep in mind some old stuff, that if the shape is slightly right skewed, that means the mean is pulled a little bit towards the tail. And so that would tell me where to look for it in those bins, which means I got to calculate all of them. So that is question 9. Let's move on to the last one. So question 10 says that we are looking at a test for ESP, and they're showing 5 shapes. You have a circle, a star, a triangle, a diamond, or a heart. A hidden screen on the computer has that shape on it, and the person is supposed to guess or use their ESP. Now, each trial, notice the word trial there, each trial, the computer is equally likely to select any of the 5 shapes, which means it has a fixed probability. My brain right now is thinking binomial or geometric just by reading this so far. And there's a lot of things in there so far that goes through. So suppose a researcher is testing someone who does not have ESP, which means they're guessing each time. What is probably that person guesses the first 4 wrong, but guesses the 5th one right? That's really what we're looking at. So I have to figure out, what does that mean? That means we are looking for no success from that person until the 5th trial. So we're looking for them guessing wrong, failure, 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 success. So I'm looking for success on the 5th trial only. That to me is telling me that I'm looking at a geometric setting where n is 5, and my probability, by the way, is 1/5 because there's 5 objects, and they have an equal probability. So I have 1/5 probability of success, which means I have 4/5 probability of failure. Notice that, because first off, I'm going to cross out D. D is the setup for a binomial situation, not a geometric situation. And based off of reading this, I can tell it's geometric. I'm also going to be careful with choices A and E. A is the probability of success, while E is the probability of failure for one trial. I have a 1 out of 5 chance of guessing it right. I have a 4 out of 5 chance of guessing it wrong. So A and E are also tricks because it's this idea of, oh, I have geometric, I have 5, probability of success is 1/5. Oh, I'm going to go ahead and say the answer is 1/5. Or, hey, we want to look at 4 failures, so I'm going to say the answer is 4/5. No. You have to calculate the geometric probability. But notice how A and E do play a role in that. So if I want to calculate it, I have to keep in mind I'm fail, 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 success. So really I'm taking fail to the 4th power, then I'm multiplying by success. So between options B and C, the answer is C. However, do keep in mind option B. Not for the answer, but how do they come up with it? The answer is C, but the way they came up with B is it does not take into account the success occurring on that 5th trial. It's only looking at the first 4 failures. But the problem says we want to know what's probably of the 5th one being a success. So we're going to fail 4 times, so 4/5 to the 4th. However, you need to multiply by that 1/5 at the very end. So the answer is C for this one. All right, so hopefully you found this video helpful when it comes to analyzing multiple choice problems, the correct answers, the wrong answers, and some tricks involved with the choices.